Most machines that get sold as income opportunities spend more time collecting dust than generating revenue, and 3D printers are not exempt from that pattern. The technology has matured to the point where a $700 desktop printer in 2025 outperforms machines that cost $5,000 a decade ago, and the category of businesses built around that technology has grown complex enough that the promotional version of the story and the operational version are describing almost entirely different realities. The machine itself is not the mystery. A filament printer takes a digital file, heats a strand of plastic, and deposits it layer by layer until a physical object exists where nothing existed before. The hardware has gotten cheap, fast, and reliable enough that a printer costing $700 in 2025 outperforms machines that cost $5,000 a decade ago. The question was never whether the technology worked. The question has always been whether there is a structure around that technology that generates meaningful income, and what that structure actually looks like when you examine it closely. There are at least 5 distinct business models operating under the label of 3D printing, and they differ so fundamentally in their cost structures, their customers, and their margin profiles that grouping them together produces a misleading picture. A print shop producing custom figurines for tabletop gamers and a company producing patient-specific surgical guides for a hospital network are both, technically, 3D printing businesses. The economics have almost nothing in common. The most accessible model, and the one that draws the most new entrants, is consumer print services. An operator buys a desktop filament printer, sets up a storefront on Etsy or a similar platform, and offers to produce custom objects for buyers who cannot or will not buy their own printer. The items that dominate this category are decorative objects, miniatures for tabletop games, phone accessories, replacement parts for discontinued consumer products, cosplay props, and personalized gifts. The appeal is real. Material costs for filament are low enough that the gross margin on any individual item looks attractive on first inspection. A kilogram of quality PLA filament costs between $15 and $30, and a small decorative object might consume 50 to 100 grams of that material. At $2 to $4 in material cost and a retail price of $12 to $25, the margin per unit looks compelling. The problem is what that margin has to absorb before it becomes income. Post-processing is the first cost that new operators systematically undercount. Support structures, which are temporary scaffolding the printer adds to support overhanging geometry, need to be removed from almost every finished part. Depending on the design, that process takes anywhere from 2 minutes to 45 minutes per piece and requires tools and skill. An operator producing items that average 20 minutes of post-processing per unit at a reasonable labor value of $25 per hour is adding over $8 of labor cost to every piece before packaging and shipping are considered. Applied across a catalog of items priced between $15 and $25, that single line item collapses the margin. Shipping compounds the problem because dimensional weight pricing from major carriers means a lightweight but bulky printed object can cost $4 to $9 to ship, and marketplace customers have been conditioned to treat free shipping as a default. An operator absorbing shipping costs on a $15 item has effectively reduced net revenue to $6 or $7 before material is deducted. The second structural problem in consumer print services is platform competition. Etsy alone had over 9 million active sellers as of 2024, and the category of 3D printed goods is among the most crowded on the platform. A buyer searching for a specific miniature or a custom organizer finds dozens of options within the first page of results, many produced by operators in countries with substantially lower labor costs, who can price below what any American-based operator can match while maintaining any margin at all. The operators who sustain consumer print businesses in that environment almost universally describe the same solution. They stopped competing on price and started competing on specificity. A shop that specializes exclusively in resin-printed dental models for hobbyist collectors is not competing with a general-purpose print shop. A shop that produces highly accurate replica props for a specific franchise with an active community of buyers is not competing on a commodity search result. Specificity is the only durable competitive position in consumer print services, and building it takes considerably longer than buying the first printer. The second model, and structurally the more interesting one, is business-to-business print services. Instead of selling to individual buyers on a marketplace, the operator sells to companies that need physical parts. The customer base includes product development teams that need functional prototypes during a design cycle, manufacturers that need short-run production of components not yet justified for injection molding, architectural firms that need physical scale models, medical device companies that need patient-specific fixtures, and engineering departments that need replacement components for discontinued equipment. The pricing dynamic in this category is fundamentally different from the consumer version. A business customer is not comparing your quote to 17 other listings on a search results page. They are evaluating whether your part, delivered on your timeline, in the material and at the tolerance they require, solves a specific problem that has a known cost to remain unsolved. A prototype that needs to exist by Thursday to keep a product development timeline on track has a value that is disconnected from the cost of the filament used to make it. Print shops with established business relationships routinely charge $50 to $200 per hour of machine time for specialized materials or tight tolerance work, compared to the $2 to $8 per hour that consumer-facing services can realistically maintain. Building a business-to-business client base takes longer and requires capabilities that a consumer shop does not necessarily need, including consistent dimensional accuracy within stated tolerances, documentation, and a communication standard that reflects a professional service context rather than a retail transaction. A single anchor client ordering 20 to 50 parts per month on a recurring basis is worth more to the economics of a small print shop than 100 one-time consumer transactions at equivalent gross revenue, because the anchor client eliminates the customer acquisition cost and the order uncertainty that make consumer-dependent operations structurally inefficient. The third model is the print farm, which is the version that appears most often in the income claim content that circulates on social media. An operator assembles a large number of desktop printers, typically between 10 and 50, runs them simultaneously on high-volume consumer products, and generates income through aggregate output rather than through specialized services. The gross revenue math is real enough. A farm of 30 printers running one 8-hour job per day at $20 per job net generates roughly $180,000 per year in gross revenue before costs. Filament consumption, electricity, labor to load machines and manage failed prints, platform fees running 8 to 15% of gross, packaging, and equipment depreciation on a 3-year replacement cycle push total operating costs to between $120,000 and $150,000 annually. The operating margin lands somewhere between $30,000 and $60,000 before debt service on the equipment and before any accounting for the operator's own time, which is a return profile that makes sense only if the operator owns the designs they are printing rather than competing on commodity print service rates. The operators who run print farms profitably share a specific characteristic. They produce their own designs rather than printing customer files. A farm that produces a proprietary catalog of items with designs the operator owns and controls is not constrained by the pricing dynamics of a service marketplace. The print cost per unit is fixed and predictable. The retail price is set by what the market pays for the specific item, not by what the nearest competitor charges for a custom print job. Print farm operators who have built product businesses around their own designs report margins on individual items that consumer print service operators cannot match, because the value of the item is determined by the design and the brand, not by the time the machine spent producing it. The fourth model, and the one with the highest barriers and the highest ceiling, is industrial additive manufacturing. This covers selective laser sintering of nylon and composite powder, direct metal laser sintering of titanium and Inconel, among others. The machines cost between $150,000 and several million dollars. The materials cost hundreds of dollars per kilogram, and the operators require formal engineering credentials and, in most applications, industry-specific certifications such as AS9100 for aerospace or ISO 13485 for medical devices. Machine hours on high-end industrial printers can be priced at $500 to over $1,000 per hour when the application requires material performance or dimensional accuracy that conventional manufacturing cannot achieve. The challenge is that winning those contracts requires years of industry relationships, demonstrated quality records, and the capital to maintain certifications while the pipeline develops, which means the barrier is less about the machine cost and more about the time required to build the credibility to fill it. The fifth model is design and engineering services, which is the layer of the business that most operators discover only after they have been running machines for long enough to realize where the real margin lives. Design services involve taking a customer from a concept or physical object to a printable file, optimizing that file for additive manufacturing to reduce material consumption and print time, and managing the design iteration process through multiple prototype rounds. These services carry margins that machine time alone cannot match because the customer is paying for expertise rather than for material and electricity. Experienced designers and engineers with additive manufacturing specialization bill at rates between $75 and $250 per hour, depending on the complexity of the application and the depth of the industry specialization required. A print shop that can offer a customer the complete service, from initial concept through finished part, including design, material selection, prototyping, testing, and final production, is selling a fundamentally more valuable product than a shop that takes a file and runs it. Many of the most financially successful small operators in this industry built their design capability before they scaled their machine capacity, because the design work both generates direct revenue and produces a continuous pipeline of print jobs. The revenue structure of a well-run small print business in 2025 rarely comes from a single one of these models. A print shop that started with consumer orders typically identifies its highest margin customer segments and migrates toward them over time, dropping the lowest margin product lines and replacing them with specialized items or service offerings that command better prices. The shops that have operated successfully for more than 5 years almost invariably describe a mix of print service revenue, proprietary product sales, and some form of design or consulting income, with each stream complementing the others. The print service work keeps the machines utilized and provides a steady cash flow. The proprietary products provide margin that the service work cannot generate. The design and consulting income provides a revenue stream that does not depend on machine time at all, which means it has nearly unlimited scalability relative to the physical constraints of running a print operation. Pricing is the variable that determines more of the outcome than almost any other factor, and it is where the gap between successful and struggling operators is most visible. New operators consistently underprice their work for reasons that are easy to understand and difficult to correct. The material cost of a print job is tangible and easy to calculate. The machine time is easy to measure. The indirect costs, the failed prints that consume material and time without producing saleable output, the post-processing labor, the customer communication time, the packaging and shipping coordination, the equipment maintenance, and the overhead cost of running a business at all are harder to quantify and systematically excluded from pricing calculations until the operator has run at break-even long enough to examine why. Print shops that calculate a fully loaded cost per machine hour, including a realistic failure rate allowance, a post-processing labor allocation, an overhead contribution, and the depreciation reserve, consistently price their work above what intuitive pricing would produce, and they sustain themselves while operators who price on material cost alone cannot. The difference between a print shop charging $3 per machine hour and one charging $12 per machine hour for equivalent work is not the quality of the printer or the material. It is the operator's understanding of what it actually costs to run the business. Utilization is the second variable that most new operators underestimate until it has already cost them significantly. An equipment that runs 8 hours of paid work per day generates roughly 8 times the revenue of an equipment that runs 1 hour of paid work per day and sits idle for the other 7. The equipment cost is the same either way. The floor space cost is the same. The depreciation is the same. Every idle hour represents a cost that cannot be recovered and an opportunity that has already passed. Operators who build a sustained order flow before scaling their equipment count consistently outperform operators who acquire machines first and then try to fill them with work. The machine is not the constraint. The orders are the constraint, and building a reliable order flow is a sales and marketing problem, which is an entirely different skill set from the technical skills required to run the equipment. The operators who build financially sustainable 3D printing businesses in the current environment share a profile that is recognizable across the different models. They chose a specific customer type before they chose their equipment, because the customer type determines the material requirements, the tolerance requirements, the service expectations, and the pricing that the business must deliver. They price their work based on full cost accounting rather than on the visible cost of material and machine time, which allow them to sustain margins through growth phases when underpricers are typically losing money without understanding why. They treated the order pipeline as the primary management problem, rather than the equipment as the primary investment, which meant they built sales relationships and marketing systems before they built machine capacity. And they consistently moved toward higher margin work as they developed the capability to deliver it, which meant their revenue per machine hour increased over time, rather than being compressed by competition at the entry price point. The technology itself continues to improve in every relevant dimension. Print speeds have increased by factors of 3 to 5 over the past 5 years for desktop FDM, which means the same machine hour produces more output than it did when current operators entered the market. Material options have expanded to include engineering-grade polymers, metal-filled filaments, flexible materials with specific durometer ratings, and food-safe or biocompatible resins that open applications that did not exist for desktop printers 5 years ago. Software for slicing, workflow management, and quality control has reduced the technical skill required to run an operation competently, which lowers the barrier to entry but also reduces the technical differentiation that operators with early expertise once commanded. Every improvement in the technology that makes printing easier also makes competition more accessible to new entrants, which means the competitive advantage has consistently shifted away from machine operation and toward the things that machines cannot do: customer relationships, design expertise, industry knowledge, and the operational discipline to run a real business rather than an expensive hobby. The income ceiling in 3D printing is not determined by the technology. It is determined by the same variables that determine the ceiling in any manufacturing or service business: the size and purchasing power of the customer base the operator has built, the margin the operator maintains on the work they produce, the efficiency with which the operation converts machine time and material into revenue, and the degree to which the business can operate and grow without depending entirely on the founder's personal output. The operators who hit meaningful income levels have solved those problems, not by finding a better printer or a better material, but by building a business structure that makes the printer productive rather than simply owning one.